Today we continue our study on Microsoft Access and database management systems. Just to remind you, the idea is to learn more about basic platforms used in business intelligence and business analytics. And one of the most frequently used platform in Microsoft is the Microsoft Power BI software, which we'll discuss in other CIS classes like CIS 240, CIS 301, and others. And these two major computer programs are spreadsheets and database management systems. We have discussed a lot of Microsoft Excel, and the previous and the current week we are talking about database management systems, which goal is to manage the resources, information system resources, both hardware and software, and available data, and provide useful tools to users to process these data and have information that may be useful and assist in making better decisions. So far, we learned about data tables, how we create data tables, how we link data tables with the help of common field and the primary and the foreign key. Then we learn how to work with Microsoft Access. What are the screens, the windows we can see there in the menus. Then we created some simple objects like using different wizards, and we created simple query, simple form and general form, simple report and general report. And then we started working on queries, more advanced queries, using the professional design, query design, professional approach in query design. And here we learn how to develop queries that match different criteria, and to make comparison between Microsoft databases, that is Microsoft Access, and spreadsheets, that is Excel, and data tables, data list in Excel. We can say that developing queries that answer different questions based on different operators is like advanced filters in Microsoft Excel using criteria range, and when we enter both criteria at the same row, this is the logical operator and when the criteria are at different rows, this is the logical operator or. In Microsoft Access, it's much easier because these two rows exist in the design grid, and it is not necessary to create criteria range. And we'll learn how to create different queries using logical operators and mathematical relations, and also to working with Belmont DB database. We develop different queries for customers with large contracts, and in June or after June with customers from Rockford, or with unpaid invoices and so forth. We also learn how to represent only top 10, the top 10, meaning how to return given number or percent of the results. And finally, last week, we also learned how to create queries with special fields that are referred to as calculated fields when the field requires some extra calculations. And it was the case when we calculated, we calculated fees for unpaid invoices. For this purpose, we'll learn how to work with the so-called expression builder. Today, we continue our analysis study on professional development and design of queries, and we'll add deeper and more advanced formulas or functions in expression builder, or when we create calculated field. To make analogy and comparison with Microsoft Excel, I would say that it is good to remember chapter 4 in the logical functions. For example, when we calculated different interests based on the amount or based on the past due date and so forth. So today we'll calculate in a similar way different fees, but first of all, let's create the criteria that we need. We can open, let me see. All right, I can use here in Microsoft PowerPoint expression calculated field. Here I will enter and I will insert new slide. Oops, new slide. New slide. Okay, like this one. And here the title, I'll call it calculated fields advanced functions. Okay, maybe just to reduce slightly. Okay, and here we will enter the rules that we will use when developing the new formula. So, rule number 1 will be if unpaid invoice amount greater than $20,000. Then fee equal 5% of the unpaid amount. Okay. Rule number 2. Rule number 2. If unpaid invoice amount is greater than $10,000, but less than $20,000, okay, then fee equals 3% of the unpaid amount. And finally, rule number 3, if unpaid invoice amount greater than $5,000, but less than $10,000, then fee equals 1%. Okay, of the unpaid amount. And finally, else, meaning unpaid amount is less than less than $5,000. No fee. All right. With these rules in mind, if necessary, I'll return to show you the slide again. We'll start now developing new query. Can we use the last query, fees for unpaid amounts, that contain the company name, the item of the invoice, the unpaid amount, the fee, calculated fee, and paid invoices? Well, yes, why not? We can use it. And before we start, let's copy paste. So we right click fees for unpaid amounts and copy. Then right click and paste and give it name advanced formulas for fees for unpaid amounts, or for, we can call it, for unpaid amount fees. Okay, advanced formulas for unpaid amount fees. Okay, and we open this query, advanced formulas for unpaid amount fees. And in design view, now our task is we can erase this calculated fee field, or we can just edit it. How? Well, we select the fee name, which contains the formula as well, and then we can open the expression builder. Here, to edit, we just need to erase and start the new calculated function or advanced formula. To show you something, by the way, this is something new. It started with Microsoft Access 2016, I believe, meaning that we can use these advanced functions. So here we can use logical operators. As I told you, we can use logical constants, or we can use a lot of built-in functions, like functions in Microsoft Excel. Some of them very similar, and we'll go straight to the most advanced, most powerful. I would say that among all functions, I mean functions, not complex procedures in Excel, the most powerful one is if. Why? Because if then else is the most useful, powerful, and so forth construction used in programming. And for example, this we'll discuss also in other classes, but when developing expert systems. The platforms they're referred to as expert shells, and these expert shells are using thousands of if-then-else constructions, meaning that if is pretty useful and common and powerful function. For some reasons, the name of the function here is not if, it's double if, or one if. Honestly, I didn't research to find out what's the name and why. Let's see, maybe the help, sometimes even help can help us. If we can see something. Okay, so it is nothing about the name. Nothing about the name of the function. Why double if? Well, we'll not waste our time. Maybe we can find somewhere else. If I find it next time, or if you find explanations, let's make it this way. Extra credit for the student who find, and next time on Thursday, tell us why the name of the function is not if, but double if. All right, so this will be a small challenge, and meanwhile, we continue here our work. So, when we click twice, the function comes straight into the expression builder window. And we have here, similar to if then else function, three parts in the syntax. Expression. We said rule number one, if unpaid invoice amount greater than $20,000, 5% fee. Okay, so we go, then this is a little bit, okay. Slowly, we have to open to use the same field names without problems in spell checking and so forth. We can type, but honestly, I prefer always to use the list with the they call it categories, but these are the field names, because otherwise it could be just a small spell error and everything will go wrong. Okay, so after we select the function, we open the available tables, and in our case, query tables. We open advanced formulas, and that is exactly what we need. And here are the different numerical fields, actually all fields that we can use, but we need the numerical fields, and this is field amount. Okay, so we click twice, amount is there. The logical operator, we can type it here, it's greater. And unfortunately, here we cannot enter references. Why not? Well, because it's impossible, and because Microsoft Access is a database management software. It's not a spreadsheet, meaning the power of Microsoft Access is not exactly an analysis and functions, but with the recent improvements and updates, we can use some functions like even if then else, though not exactly in the same way as we did in Microsoft Excel. So we just enter here 20,000, no currency, $, no separator, 1000 separator, and we continue. We continue with the second part, true part. Like if the nails in Microsoft Excel, the comma, we can interpret the comma after the condition, after the expression is then. Meaning, if amount greater than $20,000, then true part. We said this will be the fee, and the fee is amount times 0.05 or 5%. Okay, false. Oh, for the false, we will create a nested if, as we did in Microsoft Excel in chapter 4. Meaning, carefully again, we go to all building functions. We select all, scroll down. When we find out the if function, we click twice. Here it is again, and we continue. Can we copy paste the first part? Yes, we can, very carefully. First, we press a delete key to erase the expression. Then very carefully, we copy, select, copy, Ctrl+C, and paste after the parentheses and before the comma. We copy paste the expression. But now we said the second rule is if the unpaid part in unpaid invoice is greater than $10,000 but less than $20,000. Okay, is it less than $20,000? Yes, it is, because we are in the false part of the first expression, which expression was amount greater than $20,000. So if true, then the fee is 5% of this amount. In the false part, we test whether this is more than $20,000, but it is greater than $10,000. Okay, so what if this is true? We erase true part and we copy paste carefully. We copy paste the expression, copy and paste between the two parentheses, two commas. And it is amount times, let's not leave intervals. Sometimes intervals are dangerous in formulas. And we multiply by 0.03 or 3%. False part. For the false part, we'll need another if. Third nested. Okay, so we have first if, then else. If unpaid amount greater than $20,000, then the fee is this amount times 5%. If less than $20,000 but greater than $10,000, the fee equals unpaid amount times 3%. If less than $20,000 and less than $10,000, next expression is if unpaid invoice amount is greater than $5,000 but less than $10,000. Okay, so we can copy paste again the rule, the expression, carefully place it between the parentheses and the comma, and here we are testing if the unpaid amount is greater than $5,000. Okay, true part. If yes, then the fee equals unpaid amount times 0.01 or 1%. So we test it. If the amount is greater than $20,000, if yes, we pay 5% fee. If less than $20,000 but greater than $10,000, we pay 3% fee. If less than $10,000 but greater than $5,000, the fee now is 1% of the unpaid amount. And what's happened in the false part? Meaning, what do we know? Rule 1, false. Rule 2, we test rule 2, false. We test rule 3, false. Else, well, else no fee. Okay, that is, we can enter here for the false part, we can enter 0, meaning fee not calculated. 0. Okay, and look, I would say, though Microsoft Access is not that powerful and convenient for developing formulas functions, in Microsoft, in the if-then-else function, it is very, very well designed, because can you see, we don't need to worry about the number of parentheses to close, because the program already added them, and we have 3 left parentheses and 3 right parentheses, and we are simply ready to click OK and run. And here we see different fees. Let's check this one. What is this unpaid amount? 20,000. So it is exactly 20,000, meaning this is the second rule. When the unpaid amount is not greater than $20,000, be careful. Equals means less or equals. That is something which is the opposite of greater than 20. So 3%. 3% of 20,000 is exactly $600. Okay, let's scroll down and look for less than $5,000. Here, all these are less than $5,000. All of them 0, which is correct. For $10,000, 1%, which is $100. That means our formula is working. Final thing, we should carefully change the name of the field, erasing expression 1 and entering fee, and we can run again, maybe for the final time. Yes, it shows fee and everything sorted descending, and we have even calculated the total number of items, that is unpaid invoices, and the total amount of fees to be collected. All right, we can save, close and save this query. Now let's quickly open the previous one that we created, fees and advanced fees, and as we can see, they're different in terms. The number is the same, but their totals are different, and this is because we use differentiation in calculating the fees when applying the advanced formula. Though still we cannot analyze in more details the unpaid amounts, invoice amounts, and unpaid fees. Last time, if you remember, I told you that sometimes as we did it, but it wasn't very useful, I would say, paid amounts from contracts. Here we calculated the difference between contract amount and invoice unpaid amount, and as a matter of fact, it wasn't very useful because we wanted to analyze the unpaid amounts, let's say total unpaid amounts, but company by company. Because, for example, here, can you see, we have Department of Neighborhood Development with the different invoices, meaning probably different projects. All right, meaning we must analyze and create like group and subtotals, maybe it's better to call it directly subtotals, which we did in Microsoft Excel with the help of subtotals and groups just before creating data lists or Excel tables. All right, let's verify how, and let's learn how to do this. So we go again to create and now query design. And we want to analyze unpaid. Okay, so we need invoices only, and we'll click and add invoice amount and whether they paid or not. So we will say we need here no, meaning only unpaid invoices, and we run. Okay, all these are unpaid invoices. Okay, so we can also remove or uncheck display, and now we see only these unpaid invoices. All right, can we analyze them? And how to analyze? We can do this with the help of the so-called aggregate or statistical, as we know them from Excel. These are the statistical functions like average, count, maximum, minimum, sum, and so forth and so forth. Microsoft Access, these functions, they, for unknown reasons, they were called aggregate functions. Well, we know from statistics, the brief knowledge that we have about statistics, that yes, these are descriptive statistics or summary measures, summary aggregate, it's close, so why not to call them summary or aggregate? And to start analyzing, we'll use in design view, we'll use totals. Totals will enter a new row. To remind you, last time, yeah, total row. And we want now to show this field, to show the sum of these unpaid amounts. But you will say, but this is the total and we can find it if we open, let's say, fees for unpaid amounts, and we enter here the totals. Sum. Let's see, are they the same? slightly different. Probably something is missing. It's in design view. Sum of all unpaid invoices. Okay, why this is different? Let's see what is the total for the from here. I'm just curious. Slightly different, but we'll see. Let's continue first and then we'll see. So we see here the total. We see here the total unpaid invoices. Okay, we said we want to see them by companies. Meaning we will need here, we will need more tables. Let's continue. So we will add all three tables. So we can create, oh, sorry, we already have, wow, what's happened? This time something wrong happened. Invoice 1 we don't need, and I'll erase it because we have the original invoice. And I will scroll. So this is the original. This is the original relations. Okay, so we have unpaid amounts, invoices. And we want, we want companies. And I'll put the companies in front of everything. And we'll keep group by as it is. And we'll run again to see what will be the result. Wow! This is exactly what we needed. Each company and the unpaid amount for each company. Of course, we can continue with totals. And here we will enter the total sum. 3,110. What was the other one? 3,000. Oh, here I needed another sum of invoice. Strange, they're different. And it's really very strange why they are different when they must be the same. But I'll think about maybe we are missing something there, because this is the same, the sum of all, there they are. These are all unpaid invoices. So no, meaning only unpaid invoices. And these are their sums. And they're grouped by companies. Okay, so here we see exactly what do we have. Maybe we can understand if we add another field. Okay, same field, let's say amount from invoices. Again, why again? I'll explain. Let's just position here. Now I will use here count. Why count? To verify how many in total are the unpaid. Okay, here they must be 91. But they're 98. For some reasons, we have 7 more, or here there are 7 less unpaid invoices. This I will verify and let you know next time, because it's really curious. They must be the same. We use the same here. No, we use amounts by invoices. And this is what we got finally as a total of all unpaid. And in the current query, we have absolutely the same in design view, meaning the amount, their sums, their totals, and their unpaid. And we count them, but now they're 98. All right, this I will verify and will let you know next time. Plus, next time we'll learn more about simultaneously or deeper analysis of the same field. As we started here, the sum of unpaid amounts or the unpaid amounts, and we can, as you can see, simultaneously analyze and find out their sums, their number, their, as we'll see, average value, minimum value, maximum value, standard deviation, and so forth and so forth. This, because it will require much more time than we have in the rest of the class, I leave for the next time, and also I will verify and let you know why this difference between the unpaid amounts that we have in two different queries that require absolutely the same there are no criteria. Anyways, so I don't want to waste your time. I will close and save this query. And we call it unpaid amounts by companies. This is exactly what we calculated. And again, I'll open it. Why the top one has no name? Because probably this is a group of families, people who use Belmont company services, and that's why there is no company name. And you know, just before I close the class, I'll just want to find one very quick verification. In this table, okay, if we use totals and we count them, these are, oops, the count, these are all. Now, if we want to see only no, okay, what is the number? 98. It seems that in fees for unpaid amounts, for some reasons, we missed 7 unpaid amounts. Because then 98, and from invoices, these are exactly 98 too. Unpaid 98. And you know, I can make it this way, count here and total here, and the total is exactly the same. Why it is different when we calculated their fees? This is something I have to verify. I will research and let you know next time. It's really strange for me because we use absolutely the same criteria. But I will not waste your time. So this is all for today. I will stop recording.